Students, good morning. Today I am going to discuss about the throttling process or Joule-Thomson expansion. Fundamentals or principles of Joule-Thomson expansion or throttling process. Throttling process is also known as Joule-Thomson expansion, or it is usually referred as isenthalpic expansion. To understand the principles behind in the throttling process, let us consider a pipe flow. This is a pipe flow in which a compressed gas is allowed to pass. During its passage, it crosses a throttling device. Throttling device means flow restricted area. Throttling device means flow restricted area. Flow restricted area. What are the examples? One is porous plug. Porous plug. Another one is partially opened. Partially opened valve. Clear? These two are the very good example for throttling device or flow restricted area. Now the experiment is a compressed gas is allowed to pass through a throttling device. This experiment is called as porous plug experiment. The experiment is known as porous plug experiment or Joule-Thomson porous plug experiment. Joule-Thomson porous plug experiment. In this experiment, a compressed gas is allowed to pass slowly through a flow restricted area or a throttling device. This is the experiment. During its flow, the gas undergoes a pressure drop. First point, pressure drop. Pressure drop means what? Loss in pressure. Say for example, this is the entering point, this is leaving point. If gas enters at 10 Newton per meter square and leaves at 10 Newton per meter square, there is no pressure loss. If the gas entering at the inlet at a pressure of 10 Newton per meter square and leaves 2 Newton per meter square of pressure, means the pressure drop is equal to 8 Newton per meter square. 8 Newton per meter square. What I am trying to say is, when a compressed gas is allowed to pass through a control volume or throttling device, it undergoes a significant pressure drop. Pressure loss will be significant. As a result, due to decrease in pressure or pressure drop, the gas experiences a changes in temperature. Second point, changes in temperature. Changes means both variation, magnitude and sign. Magnitude and sign. Magnitude means temperature can increase or decrease. Increasing temperature or decreasing temperature referred by magnitude. Sign means positive or negative. The positive or negative magnitude increase or decrease depends on the nature of the gas. Nature of the gas. Increasing temperature means it is a heating effect. Increasing temperature. If temperature increases, it becomes a heating effect. If temperature decreases, it is known as cooling effect. All the gases except hydrogen and helium, all the gases show the cooling effect. All the gases shows a cooling effect. Okay. First point, what is the throttling process? Now I am going to provide a perfect definition for throttling process. For that, we conduct an experiment, pipe flow experiment. In this experiment, a compressed gas is allowed to pass through a throttling device. Throttling device is nothing but it is a flow restricted device. Examples of flow restricted device are porous plug or partially opened valve. The experiment is popularly known as Joule-Thomson porous plug experiment. Leave it. When a compressed gas is allowed to pass a throttling device, it undergoes a significant pressure drop. Due to loss in pressure, the gas experiences a changes in temperature. Changes in temperature means variation in magnitude as well as sign. Magnitude indicates either increase or decrease. Sign indicates positive or negative. Increasing temperature or decreasing temperature, the phenomena depends on nature of the gas. Increasing temperature means heating effect. Decreasing temperature means cooling effect. Most of the gas, almost all gases except hydrogen and helium, shows cooling effect. Clear? Now I am going to provide definition for throttling process. Throttling process. Throttling process means a process accompanied by a change in its temperature resulting from reduction in pressure. Clear? This is the perfect definition for throttling process. A process accompanied by changes in temperature resulting from reduction in pressure is called the throttling process. What next? Joule-Thomson effect. Next perfect definition for Joule-Thomson effect. Joule-Thomson effect is a process accompanied by a decrease in temperature as a result of decrease in pressure. If you are telling changes in temperature, this becomes throttling process. In throttling process, temperature may increase or decrease. If you come to the point of Joule-Thomson effect, you should say decrease in temperature with respect to pressure, because Joule-Thomson effect is called as cooling effect. You should say decrease in temperature. This is the perfect definition for Joule-Thomson effect. What next? Joule-Thomson coefficient. Joule-Thomson coefficient. Before entering into this discussion, coming to the picture or experiment. See, in this end, that means at the edge of the throttling device, the gas expands suddenly. The process is sudden expansion. Due to sudden expansion, the process may be assumed to be adiabatic expansion. The process may be assumed to be a adiabatic expansion. First point. Since expansion occurs very short span of time. The expansion may be assumed to be an adiabatic expansion. Clear? First point. Second point, there is no suitable mechanism to convert this expansion into work. No suitable mechanism to convert this expansion into work. Hence, work done by the system is zero. In this experiment, what we are able to understand means this expansion is a sudden expansion process. Expansion takes place within a short span of time. Hence, the process may be assumed to be adiabatic expansion. Point number 1. Point number 2. There is no suitable mechanism to convert this expansion into work. Hence, work done by the system is equal to 0. These two are important points. Q is equal to constant, dQ is equal to 0, dW is equal to 0. First law of thermodynamics says that changes in internal is equal to dQ minus dW. Both term gets cancelled, so du is equal to 0. If du is equal to 0, enthalpy is also 0. Changes in enthalpy is also 0. How? Definition for enthalpy, H is equal to U plus PV. Changes in enthalpy is equal to du plus differentiation of the product of P into dV. Already dV is equal to 0, du is equal to 0. The product of PV is equal to work done. Work done by the system is 0. Again, changes in enthalpy is equal to 0. Changes in enthalpy is equal to 0 means enthalpy is constant. Hence, throttling process or Joule-Thomson expansion is called it as ice enthalpic expansion. Enthalpy is constant. Clear? Right. Coming to the point of Joule-Thomson coefficient. Joule-Thomson coefficient mu Jt is equal to changes in temperature with respect to pressure at constant enthalpy. Joule-Thomson coefficient is defined as rate of change of temperature with respect to pressure at constant enthalpy. This is the perfect definition for Joule-Thomson coefficient. Rate of change of temperature with respect to pressure at constant enthalpy. Clear? Right. What about the sign of Joule-Thomson coefficient? What about the sign for Joule-Thomson coefficient? One is positive sign, another one is negative sign, another one is 0. Positive sign means cooling effect, a decrease in temperature. Negative sign means heating effect, an increase in temperature. If Joule-Thomson coefficient is 0, there is no heating effect or cooling effect. For an ideal gas, Joule-Thomson coefficient mu is equal to 0. For an ideal gas, Joule-Thomson coefficient mu is equal to 0. At what temperature Joule-Thomson coefficient is equal to 0? The temperature is called as inversion temperature. Inversion temperature means inversion temperature. Ti. Each and every gas has one particular temperature. At that temperature, the Joule-Thomson coefficient becomes 0. There is no heating effect, no cooling effect. At that temperature is called as inversion temperature. Clear? Joule-Thomson coefficient for ideal gas is equal to 0. If it is positive, it is a cooling effect. If it is negative, it is a heating effect. This is the brief information or fundamentals of throttling process. Throttling process is also known as Joule-Thomson expansion or ice enthalpic expansion process. This equipment is popularly known as Joule-Thomson porous flux experiment. Thank you.